Science is one part of life, but also doing science, you think about dedication. And my dedication is not only my wife that you see on the picture, but humanity in general. You are good, you are bad, I don't care. All I care is change. I'm the same, moral, immoral, smart, unsmart, with all of the features that are good, not necessarily bad. Let's start to do some work, as you see on the picture. Video number 6, Coleman, 1956. Using free energy device made of a compound put into the glass tube 45 millimeters long and 5 millimeters inside. We see also a COA device here working without any battery, but using ferrite yoke, the same one as group with Arunas Aidas and me used in Lithuania. Andrea Rossi is using, I believe, only one part of the phenomenon, which is the heat exchange. And of course, he probably is using the lead gloves and a special lead apron. Sometimes it's useful to have a 1-inch thick lead bags used in medical industry for gamma radiation, if you have one. Now we see the schematic of Coleman, and suggested material is generator. This is the amplifier made in Israel, just input and out, nothing else. 28 volts required, about 100 watts. So it depends from what you deliver from the generator, you have it. And then it's a setup. Now you see in this setup pretty much everything that I have used in that experiment. That is a part of the electronics. The dummy load is on the top horizontally, and this is the antenna tuner. Might be by MFJ. The model number is readable. Another generator I have used was just the generator on low frequency, 20 Hertz to more, just trying to tuck the generator on left hand side. And this is again antenna tuner in close view. So this thing works from 100 megahertz to 500 megahertz somehow, and the structure of the tube and all of the construction details, I have presented that in previous parts of it, just for those who didn't see it. Of course, it helps to have a certified, but it doesn't have to be certified, a beta radiation box, and in case there is any radiation. Another device is Ranger, and that one not only identifies gamma, but also gives a detection of neutrons and assign a certain contents of unknown to the mathematical algorithm that is built into it, and gives you the precise information what is there. Michael Mayer made a very much similar device, so Coleman was not really the first, I wasn't really the last. The purpose of this video is to present you all of the very accurate details of how we made the compound and introduce you to the progress.
Oh boy. Yes, I saw it moved.
Look, you might be facing right now the historical moment in a lifetime. As close as I was possible to present, I give you details about Harold Coleman, 1956, free energy device.
put it in here. Don't show it to anyone. Look at the on the plate. We are trying to make extra. People won't gonna take us seriously.
No, they will.
Don't put it on YouTube. There's this kind of situation.
No, this is how to make the copper by yourself.
They're not gonna believe it. Where's this all?
That's how you make the copper powder. Yeah. Okay. So that's how we made the copper. Most of the chemicals we were able to achieve. The copper was something that we couldn't buy, especially powdered copper, conductive one. So the important factor is to have a zinc and a copper in conductive form, not oxide. And we took the bright from the coaxial cable. Conductive copper. And that's what you see. Yeah, it's good.
Enough for tonight.
Yeah. No, make it all of this.
Yeah. Take some time.
Yeah. Scientific experiment. Okay.
Okay, let me do.
Yeah. Okay, and I'm gonna put a little bit more light. Okay. Okay, so now I put 50 milligrams of this.
Yes. Can you see
Yes.
how it's going on? 50 milligrams.
So far it's not going. I have to have 0 and 5
Yes.
here.
See, 5 milligrams is really hard to.
Yeah.
Just make it 10 times. It's easier.
So 26, 50, 50, 62.
Oh, 50.
I put 62.
Get it back.
Yeah. Huh. That's a nice stuff. I wasn't playing with it before. I love it.
What is now?
Okay, 52,
Okay.
54. Can we stay with it?
Yeah,
or,
yeah, yeah.
or you want to take it out?
That much is okay, I think. If you
50.
can, you can, but
Yeah, okay, I can.
it will be hard to 2
No,
milligrams.
no, it wouldn't be hard. I'm getting better and better with it.
Okay.
Okay. Okay. I think. Okay. I think I'm okay with that. There will be 51 right now. Still 54. Oh. So now I know how much I have to take it out. Okay. Now. 52.
Okay. I think that's fine.
Let me just train it.
Okay.
Okay, now. $48. No, see that this thing either show 48 or either show 50. Depends how you put it.
Yeah,
But
that much is, I think.
it's okay. I make a little train myself.
Okay.
with it. Okay, 50. Haha.
Perfect.
Okay. So the cobalt nitride.
Yes, it will be
Now-
100 milligrams.
Now, this is 100 milligrams. So whenever it's 5, 50. Whenever it's 10, it's 100. Cobalt nitride.
Ah, what did you put that? Wait. This was calcium chloride, right? What you put, or
This one.
that one?
Yeah.
Ah, sorry. It will be 150 milligrams.
This one.
Yes.
Okay. Oh,
But
because this
150 milligrams, but
of the last one.
yes, 100
Okay.
no, wait, 150 milligram, right? But
Yeah.
among the 150 milligram, you see, this will be 35 milligram, and the other will be 150 milligram
Okay.
carbon black. So this is excess. This should be 35 milligram.
This should be 35 milligrams.
You use that, right?
Yes.
Okay.
So I have to have 35 milligrams.
Yes, of that.
Okay.
Sorry, that was a mistake.
That's okay. That's okay.
35.
Okay. We have a 30. Let me put the 32. 32, and I'm gonna put another 30. It shows 30. 5 milligrams.
Yeah, 35.
35. 35.
Yes. 35.
Actually, it's not that difficult. I thought it's gonna be with my hands. It's gonna be more difficult, but it's 32, 34. $36
Yes.
is okay?
Yeah. Plus
Okay.
minus 4% is good.
Okay, so
Okay,
32.
and 115 carbon black.
115 carbon black.
Yes. This, I think you should use this one because it's not easy to get it out from that. And then you should make it 0. Okay.
0.
Okay, now add 115.
115.
Yes. You should be careful, you cannot get it back when you mix it once.
Yeah, I know. Oops.
What
Look
was
what
that?
I did.
Yes, this is a lot
This is a lot. Now I can
So-
I can make it. I can take it out.
somehow.
No, don't worry
With
about.
this,
I see what
this
you say.
carbon black is really nasty. So
No, don't worry about it. We're gonna take it out.
you can use this part of it, and you can get it back slowly. It might take some time, but you will do it. Yes, something like that.
No. I can take this.
Okay,
182.
still a lot.
Still a lot. It's supposed to be 100 what?
15.
166.
Still a lot. 120 or 110.
154.
Still,
Still a lot.
yes.
Hold on, let me turn that. $142.
Still 20 grams.
$116.
It went up.
What?
It went up.
Yeah. It should be good. 116. You said 116.
115.
Well, I have 116 right now.
Why that happened? Because you took it off and put it back.
Okay.
And
So
there was 35 milligram on that, and plus 150. Okay, it's good.
it's good.
Good.
You sure?
Yes. Okay, now the others.
Okay. Now, which one?
Okay, we were in the third. Now we go to the second. It was
CdCl2.
yes,
CdCl2.
yes, cadmium chloride.
Oh shit! Both of them are alike.
Yes, that's why I asked which one you mixed.
I don't know.
I think that is cadmium chloride.
This is cadmium chloride.
Yes.
Huh. Okay. How many?
You should make it 0,
0.
and then you should put 100 milligrams.
I'm gonna be extra careful. 90?
Okay.
90 is okay?
Yeah.
You want me to go more?
The 95 would be better if you can.
Yes, I can.
Close to 100.
98.
Yes, perfect.
Okay.
And then the first one
And the first one?
is,
This one.
yes,
How much is the 50 milligrams?
yes. You should put that 0 first.
Okay. Now.
Okay. Cobalt nitride.
What's happened? The cobalt was wet.
Yes, because it's hydride.
Okay, so now I waste a little bit of this, but I think I can be able to retrieve
Yes.
100 milligrams.
No, no, 50.
$50.
Yes.
48.
Yeah, it's good.
50.
Yes.
Okay, now.
Now you can take this off. This is all done.
Okay.
Okay.
I can try to
Okay.
try to put that back.
You just pour everything on this. This one.
Okay. Good.
That's it.
Aha. And
So you should mix this.
the first, I'm trying to save this. So we have that clean. Okay. Okay, now I'm gonna close that. And now we need to mix that.
Yes. It will be really black. Because carbon black is paint, almost black paint. You can break down the nitride, the cobalt, because they are kind of big grains. You can crush them. Yes, something like that.
See, with you I would learn chemistry very well.
Yes. I think it's done. Good. So now the filling up. Filling up can be
Okay.
as you like.
Okay, well, what I do is I put the paper on it, so whatever.
Maybe I think you should first, like as it says, little bit of copper or maybe little bit of zinc.
Oh, okay,
Yeah,
okay.
that is the thing.
Starting with zinc.
You don't need to measure it, just somehow
Okay.
evenly you try to place it.
Now that would be a little difficult to put it like that. Can you hold the tube for me?
Yes.
Thank you. No. I have something here already,
Hmm.
but
Yes, something
Okay.
like that.
I think I'm wasting too much. Okay, that's good or it's not so good?
Yeah, that's good.
That's good.
So you
Okay.
put back. You put back.
Yeah,
the zinc.
but we had that beach.
Yeah, something like that. What we did that before. You can put the zinc back.
Go ahead. Okay. Now you can stop that because we're gonna. So how much cobalt?
50.
50.
Yes.
Okay. 50.
This is that.
So that was the first one.
Yes. Cadmium chloride.
Now cadmium chloride.
100.
100. $96. We need a little bit more. 98. You are good in it.
Yes.
Okay.
This
Cadmium chloride.
cadmium chloride. No.
Okay. You have it.
No.
CDL silver.
Calcium metaphosphate.
Calcium metaphosphate.
Yes. This is 25 milligrams.
35 milligrams. So that would be the position number. Well, the position number 3 is 15, right?
Yeah, I'm making 10 times.
That's 150.
Yes, and
So why you say 130?
this is 150 is composed of 35 milligram and
Oh.
100
He says, I see 35 milligrams and 5 milligrams.
35 milligrams and 115 milligrams of carbon gas.
Now we have a 15 milligrams, that would become 10, so it would be 150 milligrams, right? And that is CaPO3, right?
Yes.
Plus carbon, 10C.
Yes.
Okay. Plus 35 milligrams plus 5 milligrams.
Yes.
Okay.
Mix those.
You're much better in it than I am. Okay.
Now we put
Okay, we put.
100 and
Oh, you didn't put the zero on it?
yeah, I just got to press.
Okay. Now 150.
115.
115 of carbon.
Carbon black.
This thing is nasty black. Okay.
100 and
115. Oh, this carbon. 104, 106. 115. 110.
okay.
You're not gonna go to 15?
No.
Okay.
It's plus minus fine.
Okay, plus minus.
And then we mix it. There's some on this too, so
Mm-hmm. Okay. You want coffee?
little bit.
Yeah?
Yes.
Okay.
Okay. This is the compound.
Okay, so made the compound. This is carbon.
Carbon black.
Okay. Now we have a conductive zinc.
Yeah, here too. And well, that
Zinc.
here.
Zinc. And we have a copper, homemade copper, out of the wire. The bride of the coaxial cable. Basically, took the scissors and we cut it. Okay. Hey, you are much better than me. Yeah. Okay. This is zinc. Okay, now we have a zinc. Now to use the bead a little bit. Okay.
Let's use something like that.
Now we're gonna put copper.
Another layer. Compound.
It's okay?
Respect.
You put zinc?
Yes.
Oh yeah, good. Zinc. Oh, a lot of zinc. A lot of zinc. That's okay.
You got the zinc out anyway?
We lost a little bit of zinc, but it's okay. We have plenty of zinc. Not worry. Now we put the compound. Beautiful, beautiful. Cobalt again. The compound. The chemical. Copper. Now the chemical. Again.
And the rest we fill with copper.
We have copper. We need a little bit more squeeze it. I'm gonna squeeze it with the screw. Let me finish up that part. We're gonna cup it. Okay, you hold the camera. Then I'm feeding. And put the feeding in and then turn it a little bit. Now this one is not holding. It's not good. It's supposed to go in half a turn and it's locking down. This one is not holding. The tube is probably a little different, but I have plenty of them.
But it is good that we can
Okay.
screw it.
No, it's okay. This one is locking.
Okay.
This one is lucky. Okay, so now we have beauty. Beauty. Okay. Now you can use it. Okay, switch it off. Let's take a. Okay. Okay, now we have a changing 11 volts. Nothing steady. The radiation level is not high. Radiation level we have on 0.5. Okay, I'm gonna put it like that. So we have 0.5 is in here, 0.5 in here, and it doesn't really show much the radiation, but the voltage that I have in here is somewhere between 10, 5, 10, 5, 11. That's the voltage. Now the frequency that I'm playing with right now is 145 megahertz. But actually what I could do is look in here and it says 138 megahertz, 145. It is 145 megahertz. That's what the C1 says. C1 is the frequency. Okay, on the spectrum analyzer we don't see anything because the probe is simply lying here. But if I put the probe back here inside through that pipe, I think it would be able to read something. It is trying to reach something here at this particular moment, but not much visible on the spectrum analyzer. And I can put the dot. I can put the dot. That means put the marker and try to tune it to 145 megahertz. Let me go like that. Forget it. Forget it. Later on. Okay. The radiation level is 0, the power is 0. What did I do wrong here? Something is wrong. Okay, now he put the gloves on his private part. There are lead gloves to protect the balls. Oh, I wasn't even recording. That's fine. Oh, I wasn't recording that. I wasn't recording that part, private parts with the lead gloves. What? Hold on.
Concentrate
Concentrate on this. He doesn't want me to show him. Okay. Now, okay. So radiation level is very small one. Okay. Well, I'm wearing this stuff, so this is 0.7 millimeter of lead. That looks funny. No, I didn't show the face, so don't worry about it. Okay.
Find me the voltage. Basically.
Okay, we have a 21 volts right now. Let's go forward. Maybe I change the frequency, see what am I gonna get. So right now 180 megahertz. I'm changing it for more. My power supply is not striking. Can you put the camera on the power supply for a moment?
Yes.
You see? So we have one amp 27, 127, 24 volts. The amplifier is supposed to be 28 volts, so we're not even giving him. Okay. So we have a 14 volts, 20 volts. Okay. Okay. Did you see that?
Yes.
120 volts, 192 volts, 166 volts, 187 volts.
Yes. Something is going on.
I hope my balls are gonna be okay.
Check the radioactivity. What are we exposed to?
No, look at the radioactivity level. Unbelievable. Come on.
I can't move. I'm comfortable like that.
You comfortable? Give me the camera. Look, it's not bad. Not bad. Radioactivity level is. I'm gonna show you like that. Okay. Okay, we have 0.5. We have a 0.5, which is almost nothing, and the minimum is on the right hand side. This is my radioactivity level. Not bad.
We check the neutrons.
Check the neutrons. Okay, we gotta check the neutrons. Make sure that we're not being bombarded by the neutrons. Okay. Okay. Well, this thing must press 0. Okay, and I have to put light on it. Put light on it. Yes, I have a light. No neutrons. No neutrons so far. Now, before we were dealing with the non-conductive copper and zinc. Right now, we made the copper and we made the zinc.
Voltage is dropped significantly again.
What is it?
Voltage is like 40 now.
Yeah. We don't know. I can check if we have any temperature on it over there. But anyhow, we're getting some progress here. Oh, I don't know how to show it. From that distance, doesn't show me the neutron count and doesn't show me gamma, but we didn't have gamma before. I can open up the door and see.
I think maybe you should use this.
Yeah. You think it's no? The radiation level is a low one. Whoops. Okay. Oh. Yeah. Hold on. The radiation level is not really harmful for me right now. I don't see any problem with that. Okay, now I'm gonna put that inside and see if I'm gonna get any neutrons. So this thing behaves quite a different way when we're dealing with the conductive copper compound. Nope, no neutrons and no gamma. Okay. Fuck. Now, the current that is drawn for the amplifier is 1 amp, 1.4 amp at 24.7 volt. It's a pity that you cannot see what the thing is showing over there, but it's blinding. Okay, I'm at 260 megahertz. Let me go further. Now I'm changing the band, and that band right now I start from 500 megahertz and go down. Okay, 500 megahertz and go down. Now I can easily adjust. Okay, tuning. Wow, like that. And the maximum power. As a matter of fact, I'm not giving big power to this. Not really delivering big power to it. Okay, right now it's approximately 5 watts because it's 30 watts is all together everything. Yeah, probably 10 watts. Okay, let me go. So I'm now changing the frequency and tuning it. 400 megahertz, I don't see much response with that compound. So it looks like the frequency of response depends on each individual compound that you make. Depends how you make it accurate. Not much response. Not much response. So for the conductive compound, it looks like but we have a radiation level. Now it's going down, and with me, okay, I'm increasing right now the frequency 300 megahertz and going up. Okay, it's going, oops, so it rapidly goes up. Okay, I go less. Now is 260, 280, and I'm approaching 300 megahertz. 300 megahertz, like in here.
And now I'm looking at the radiation level. It's going all the way up. Okay, what's going on with the voltage? Not much voltage. It's 1 volt and something like that. Nope. So we gotta come back to 130 megahertz to 260 megahertz. See, every time that we measure something, we have a difference showing. Okay. Okay, 13 volts, 13 volts, 14 volts, 57 volts, 61 volts. Well, definitely 150 something volts. Okay, definitely something is going on. And big one. Okay.
What are you now?
I'm not looking at the scale of Bradiac right now. I don't want to show it in the camera. How much we're getting. But you have your balls protected, so don't worry about it. I have my balls protected as well.
What frequency you are now?
270 megahertz.
270.
Yeah. Well, that's
Optimum.
yeah, 84 volts. Okay. Now I'm slowing it down. Okay, 105 volt. The frequency response is 263 megahertz. 263 megahertz. That's what it is. The frequency of the response.
Showing 0 voltage.
Well, it shows 0 voltage, but it jumps to big one. We don't know what's going on over there. We just have a first time something that is sort of very much similar to the one that is supposed to be. Okay, 140 volts. Nothing steady so far yet, but we're getting close.
I wonder about amps.
I can change it to amps, but I don't know what we're gonna get. Okay, so we have to go like this, and then shortage goes to amps, and then shortage amps. We have, okay, we have 1 amp, 154. So the progress is being made. Part number 7 will give more details and maybe a little bit more excitement, I believe. And it's not only one technology that is interesting here. The general approach is to assign the energy extraction to unstable nuclei. As you know, the gluons and the atomic bonds requires pretty high power to extract something from it, or to eventually get it to the unstable stage. So one of the scientists that I spoke to said, Wesley, if it's true that you are able to turn ordinary matter, non-radioactive matter, into the unstable stage, which is the radioactivity stage, this is a Nobel Prize. So then my response was, well, who's gonna get the Nobel for it? And what is next? Would that be Coleman, who is very much dead for a long period of time? Would it be me, or would it be anybody else? Honestly, it's not important. The whole task, the whole activity is for much higher priority than benefit of one man. But there is something interesting there. I wouldn't like me to sound funny, but being able to change the properties of ordinary matter, it's not only electricity, it's not only energy, it's much, much more. And the legal note, as always, must be never do anything with it, never touch it, never smell it, never even look at it. Have a good day.